right, today what we're going to do is we're going to look at solving polynomial equations in factored form. So we're going to start looking at factoring a little bit. You use this some in geometry, but you really use it in Algebra 2. So if you can somehow save some of these notes for when you take it, it would be a good idea. Okay. So first of all, it asks you to solve. Okay. So what you're going to do is this. I'm going to take this first parentheses and I'm going to set it equal to 0. And then I'm going to take the second parentheses and I'm going to set that also equal to 0. And you're going to see why in just a minute. Okay? So if I take this now and I solve for x, I'm going to add 5 to both sides. Notice I'm showing my work. And x equals 5. Then I take the second equation. I'm going to do what with it? That's correct. I'm going to add 4. So x equals 4. And that's my second answer. You go, well, Mrs. Medvik, how can you have 2 answers for a problem like that? Well, let me show you. Now, this you don't have to do, but I want to show you why this works. So if I have x minus 5 times x minus 4 equals 0, let's say x equals 5. Okay, let's just say. So if I plug 5 in and I do my order of operations, 0 times 1 is 0, and it works, doesn't it? So if x is 5, that works. It's true. Okay. Well, let's say x equals 4. So if x is 5, it'll wipe the whole thing out. If x equals 4, it'll wipe the whole thing out. Those are the only 2 numbers where that is true. Right? And you go, well, what's going on? Like, that's really weird. You're going to see why in a couple of days. What's going on is you have a parabola. A parabola is a U-shaped graph, and that's where the U-shaped graph crosses the x-axis. So you're going to have 2 answers on these, because it's going to be a quadratic equation. Okay, it's not going to be linear, it's going to be quadratic, and so something different happens, right? So again, when you do your homework, you only have to do the red and the blue. You do not have to do the black, but this is what works, and this is why it works, okay? All right, let's keep going to the next one. So if I have this problem, I'm going to go x plus 6 equals what? 0. And I'm going to do x minus 3 equals 0, okay? What do I do with the red? Subtract 6. X equals negative 6. And with the green, I'm going to add 3, and I get x equals 3. Again, this is not linear. If I graphed a line, x could only be one number. Okay, or many solutions. It could be a many solutions, but it's one solution, no solution, many solutions. Okay? With the parabola, you can have 2 solutions, and in this example, it is 2. We're going to see this in play later. So I'm just kind of dabbling a little bit, and then I'm going to let the skill go, and then later on, I'm going to pick it up again. Okay? All right, let's go on. This asks me to factor out the greatest common factor, and you did this in elementary school. Okay? You actually did it in 7th grade. So this is what you do. How many terms does the number 1 problem have? It has 2, doesn't it? Yep. One of the terms is 16x, and the other one is 40y. So when you do these, you take each term out. Right? Now what we're going to do is off to the right-hand side, I'm going to take 16 and I'm going to do the factor tree. So you remember when your teacher did the factor tree and you're like, when am I ever going to use this? This is so lame, like I hate this. This is where it comes into play, okay? So I can break 16 down into 4 times 4. Now there's other ways to break it down. Is 4 prime? No, it's not prime. So I'm going to break 4 down into 2 times 2, and these are prime, and I circle them. Please circle them when they're prime, because when you actually do the problem, it makes so much more sense. Okay, and then I'm going to break this 4 down into 2 and 2, and again, I'm going to circle it. Now, I could have broken it down into 2 and 8 and circled the 2, break 8 down into 4 and 2 and circle. You can break it down the same way, it's still right, okay? So now after the 6, I'm going to write these down. 2 times 2 times 2 times 2 times x. All right, now I'm going to take 40 and I'm going to do a tree. So what does 40 break down into? 4 and 10. Is 4 prime? No. Is 10 prime? No. Neither of them are. 4 is broken down into 2 and 2. Those are prime. And what does 10 break down into? 2 and 5. And it's 5 and 2 or 2 and 5. It doesn't matter. Okay? So again, you're like, oh, I don't need to know this stuff in 7th grade. And then it comes back and it kind of bites you. This is going to help you when you get into Algebra 2. Right? So now I'm going to list them, and I list them in order, and you're going to see why. So you're going to go 2 times 2 times 2 times 5 times y. And yes, I want those numbers in order from least to greatest. And this is why. What I'm going to do now is I'm going to take the greatest common factor. It's called the GCF. This is on your MCAs. This is on your NWEAs. It is on your ACTs. Because you factor stuff out. Now, I'm looking to see what they have in common. Okay? So I'm going to circle a set of 2's. And I'm going to write down a 2. So they have to have a set, and I only write 1 down. I'm not going to write 2 down. I'm only going to write 1, because it's 1 set of 2's. And then I have another set of 2's. And then I've got another set of 2's. And is there anything else I have in common? No. 2 times 2 times 2 is 8, and that is my greatest common factor. Okay, now, some kids will go, well, I could do that in my head. Great, but eventually they're going to give you numbers that you can't do in your head, and they're too difficult to do, and this process will always work. So if you have this process and you can double check using common sense in your brain, awesome. Questions on this? Okay, let's move on. How many terms are in this one? There's 2. So I'm going to go 6x squared, and I'm going to go 30x cubed. And I'm going to break down 6. I'm going to leave the variables. Variables are easy to break down. Numbers not so much. So 6 can be broken down into 2 times 3. So I'm going to go 2 times 3 and put 2 first. Reason is if you don't put it first and you're circling them, the circles crisscross and it's really confusing because there's a lot of writing going on. How many x's are there? 2. So I'm just going to go times x times x. Right, now I'm going to break down 30. What can it be broken down into?
3 and 10.
Okay, 3 and 10. There are other ways, and that's okay to do it another way. Is 3 prime? Yes. What does prime mean?
Not very popular.
I can't break it down anymore. The only factors are 1 and 3. Okay? Do you know what 10 is called? If it's not prime, it's composite. Very good. Yep. Again, who cares? Well, in your ACT, you should, right? Or your MCAs, your NWEAs. Those are words that you'll hear. Okay, so you don't want to get that wrong because that's not a hard thing to know. So I'm going to break down 10 into 2 and 5 or 5 and 2. Again, circle them because then when you pull them off to the side, it's easier to see. All right, so I'm going to go what first? 2 times, 3 times, and how many x's? 3. If you line them up, it's so much easier. All right, greatest common factor. Okay, what can I circle? I can circle a set of 2's and I put down 1, 2. I can circle a set of 3's. I can circle x's, yes. So I'm going to do 1x, and I'm going to circle another x. Yep.
Why can you go diagonal with the x? Can you go diagonal with the numbers?
I can go diagonals with the numbers when I'm looking for pairs. And so that's a good question. I'm going to finish with this and then I'll show you, okay? So 2 times 3 is 6, and it's 6x squared. Okay, so the question was this. Notice my x's are kind of diagonal. Okay? Well, it had everything to do with my lining up. So for example, if I didn't put it in order, and I did x times 3 times x times 2, and my 30x cubed I put down as 2 times 5 times x times x times 3 times x. Let's say I didn't care. I'm going to write down however I want in whatever order. Okay? This is what I mean the diagonals get confusing. All right? So notice that I've got 2's and x's and an x and a 3. That's a pain. And it's very messy. So when you do that, you don't want to do that. You want to line them up from least to greatest with your variables on the end. And yeah, they kind of go on a diagonal, but that's a lot less confusing than the bottom. Does that answer your question? That was a good question. So 5, he doesn't have a partner. And you go, well, where do those go? Like, what about the 5 and what about the x? Like, where do they go? I'll show you that later. Okay, we're not going to do that right now. Right now, they're just asking me to find greatest common factor. Yep? I would circle the pair. So when you circle the 2, you write it down. When you circle the 3, write it down. The reason why I have you do that is what kids will do is they'll like, oh, I got 2 2's, so they'll write 2 2's down. So when you circle the pair, that helps you. Okay, I only write 1. Good question. Any other questions on this? It's not hard. You've done it before, but I'm applying it. Okay. All right, let's keep going. I'm going to solve this equation. Okay. Now to solve it, what we're going to do is this. I have to factor it out. So what I'm trying to get it to look like is like this. Okay. So I'm going to do greatest common factor stuff. So I'm going to go 3x squared, and I'm going to do 15x. You okay? I got my 2 terms. All right. So I'm going to pull out my 3. What do I notice? I can, it's prime. So this is 3 times x, and I technically don't even need to do my tree. That's like, that was a waste of time. Okay, now my 15 can be broken down into 5 times 3, and I'm going to circle them because they're both prime. And what do I write down first? 3 times 5 times x. Okay, now I'm going to do my greatest common factor. So far I'm doing everything that I was doing. What do I circle? I circle one set of 3. So I'm going to go 3. Can I circle anything else? Yes, I'm going to circle my x. Is there anything more that I circle? No. Okay? So I found my greatest common factor. Now, I'm not done yet. We're going to do my favorite part. This is my all-time favorite part. It is called the leftovers. You know, in Thanksgiving where you had the big turkey, and then you go out, you do whatever with your family, and you come back that night, and you have the leftovers, and you warm them up, and they're almost better than the real stuff. Especially like the cheesy potatoes, and they get kind of crusty because they've been in the oven for a while. And, oh, it's so good. Okay, so this is called the leftovers, right? So what we're going to do is we're going to put the greatest common factor out front. I'm going to put it out front. And then I'm going to do a parenthesis. Now, go back to 3x squared, and you see I have an x that's left over right there? That was a leftover. So I'm going to put that down here. I'm getting it. Okay. Now, do you see in the problem there was a plus sign that separated the terms? I'm going to put that next. Then I'm going to go to this part, and you see how my 5 was a leftovers? I'm going to put it here. And I'm going to set it equal to 0. See it? Okay, now this brings us back to this very beginning. Do you see how we set the first part equal to 0 and the second part equal to 0 and we solved? Okay, we're going to do that. So I'm going to take this. I'm going to go 3x, oops, we got fancy. 3x equals 0 and x plus 5 equals 0. So how do I solve for x with the black? I'm going to divide both sides by 3. X gives me 0. What do I do in the red equation? I subtract 5. X gives me negative 5. So if x is 0, it would work. And if x is negative 5, it would work. What's happening is if I were graphing a parabola, which is what you will do eventually, the parabola will cross the x-axis at 0 and negative 5. That's what's going on. Okay? So we're using these skills now, and I'm teaching you something, and then eventually we're going to pick it up at the end. All right, let's go on. Now, do you remember on your quiz that you just got back, I told you that it needed to be in standard form? Okay? Is this equation in standard form? It is not. How do I get this in standard form? I either have to subtract 9b squared or I have to subtract 24b, don't I? I have to get it all to one side. That's what it is. Okay, so what we're going to do is I don't like the first number being negative. So I'm going to subtract 24b on both sides. And I get 9b squared minus 24b equals 0. Okay, and this is standard form. So that's like step 1. So it's getting a little confused. That's step 1. You need to make sure it's in standard form. And they've been in standard form so far. Okay? Why can't I add the 9b squared and the minus 24b? One is squared and one is not, so they're not like terms. You remember when we talked about that before? They have to kind of be like terms. Okay, so I got standard form done. Now the second step, I need to find the GCF. Okay, so what's my first term? 9b squared. What's my second term? 24b. Okay, is 9 prime? No. So I'm going to go 9 and I'm going to break it down into 3 and 3. So 9 is 3 times 3 times b times b. Again, none of this is like, oh my gosh, super hard. It's the process and remembering the process and how you do it. Okay? Okay. Now I'm going to break down 24. 24, what do you want to break it into? Sure, 4 and 6. Are they prime? No. Okay, 4 is 2 and 2. 6 is 2 and 3. So I get 2 times 2 times 2 times 3 times b. Okay, and this is a little bit like diagonally, okay? If you want to scooch the numbers so that they're right underneath each other, you can. I've got a 3, greatest common factor is a 3 and a b.
You want us to do the innermost number?
Does it matter what numbers you circle? No. Just as long as they're the same. So if you want to do the inner ones, that's fine. We okay? Questions? Okay. So now step 3 is, I call it the leftovers. And it sounds really stupid, but it's the thing you'll remember. Okay. So what goes out front? 3b. And then I'm going to do a parenthesis. What's my leftovers in the first term? 3 what? 3b. Right here. Leftovers is the 3 and the b. And I'm just doing this for notes. I wouldn't actually circle those in the problem. They might become confusing for you. Okay, now what sign goes between those?
What about the 2 sign?
A minus, a subtraction right here. Okay, so I'm going to put a minus. Okay, and now I'm going to look at this. What's my leftovers? 3 2's, which are 8. And set it equal to 0. So 2 times 2 is 4 times 2 is 8. You okay? Questions?
Will we
Okay.
ever have to find b?
I have to solve. Yeah. Yep. Fourth step.
Oh.
Solve. Okay. So I'm going to go 3b equals 0 and 3b minus 8 equals 0. So I set each piece equal to 0. The GCF and the stuff in the parentheses, my leftovers. Okay, how do I solve for the first part? Divide by 3. B gives me big fat 0. Okay, the next problem, what do? I'm going to add 8. So 3b equals 8. And then I divide by 3. B gives me 2 2/3. Yeah, and you can either do that or you can say 2.6, but it has to be repeating. Either or. I tend to do fractions just because I find it easier, but you might not. Okay? So the parabola crosses the x-axis at 0 and at 2 2/3. Okay? Are there any questions? Something you don't understand? Yes, sir.
Why can't we divide?
Because when we solve hands-on equations, if you remember, it's the opposite of the order of operations. Okay, so that's a great question. You could divide by 3 first, but if you do, it affects the 8, and so you'd have a fraction with the 8 and you have a fraction with the 0. So you add and subtract and then you divide. So do you remember the hands-on equations? When we did that, it's the opposite of the order of operations. That's a great question. Any other questions? Okay, that's it for today, and we'll go ahead and start on our assignment.